Drop a piece of ice into water and it floats. Yet at the molecular scale, ice is simply water at its coldest. Why does the same molecule become less dense when it freezes? Water is not magical. Its strange behavior begins with a bent molecule carrying directional electrical charge. Now let us dive from one drop of water into its hidden molecular world. A water molecule contains one oxygen atom and two hydrogen atoms. Two lone pairs around oxygen push the molecule into a bent, V-like shape. Oxygen pulls the shared electrons more strongly, leaving the oxygen end slightly negative and the hydrogen end slightly positive. That is polarity, not a full transfer of charge, but an uneven distribution inside shared bonds. Because its ends carry different partial charges, a water molecule approaches its neighbors with direction. A slightly positive hydrogen end can attract the slightly negative oxygen end of another molecule, forming a hydrogen bond. Hydrogen bonds are much weaker than covalent bonds, yet in liquid water they constantly form, break, and form again. Water becomes a molecular network that is always rearranging. In liquid water, the network is loose and crowded. As it cools, slower molecules settle into a more open arrangement held by hydrogen bonds. The crystal lattice of ice spaces the molecules out and leaves extra gaps. That makes ice about 9% less dense than liquid water, so an ice cube floats. It also lets a lake freeze from the top while liquid water can remain below. Water is also good at absorbing heat. Raising 1 gram of water by 1 degree Celsius takes about 4.184 joules. The energy is shared by molecular motion and the hydrogen bond network, so water does not change temperature easily. During evaporation, the fastest molecules are more likely to escape the surface, carrying energy away and cooling the liquid left behind. That is one molecular reason sweat, oceans, and climate systems depend on water. Water's polarity also makes it a powerful solvent. When a salt crystal enters water, the oxygen end points toward Na+, while the hydrogen end points toward Cl-. Rings of water surround and separate the ions, forming hydrated ions. Many polar substances can disperse in the same way. But water is not a universal solvent. Oil does not carry the same charge pattern, so the two liquids separate. Remember the water molecule in 3 sentences. Its bent shape creates polarity. Polarity gives molecules direction. Hydrogen bonds connect that direction into a changing network. That network helps explain floating ice, buffered temperature, evaporative cooling, and dissolved salt. Next, we will follow invisible charges again. How do acids and bases change the world? Protons, pH, and buffers take the stage. See you next time.